Thank you very much. Thank you. Thank you very much for all the PyData team for having me. Okay, let me share my screen here. And thank you very much everyone for assisting to the talk. It's great to see this amazing community. So let me share here. I think you should be able to see me now. Can you see me?
Yeah, works great.
Awesome, perfect. Okay, so we're going to talk about, let me minimize this. Yeah, we're going to talk about serving machine learning easily with FastAPI. So FastAPI is a high performance, easy to learn, fast to code, and ready for production framework. This is what we're going to talk about. So first a little bit, who am I? I'm Sebastian Ramirez. I'm a developer at Explosion in Berlin, Germany. I'm actually originally from Colombia. That's why the accent. You can find me on GitHub, LinkedIn, Twitter, everything. I work for Explosion. Explosion are the creators of SPACY, which is the natural language processing toolkit that you probably know of for doing like machine learning processing over text. Prodigy, which is the annotation tool with active learning so that you can annotate your data sets while retraining the model live while you add annotations. And Think, which is the deep learning framework using type annotations and functional programming ideas. I personally created FastAPI and Typer. We are going to talk about FastAPI. So what's about FastAPI? FastAPI is this framework that now has like 15,000 GitHub stars. It's been growing for about 1,000 stars per month in GitHub, so people seem to have been liking it. It's currently used by Microsoft, Uber, Netflix, and a bunch of other people for products and for their internal systems. And the performance is in the top rank for Python. But why would it be useful for machine learning people? Like, what is the deal about it that will make what makes it make sense for machine learning? So that's what we are going to see. So I will assume you know machine learning. You know the basics of web API development, like just the basics. I mean, just HTTP, JSON. You know what's an HTTP request? Just that, nothing else. So FastAPI is based on, let's talk about like a little bit of what is FastAPI and what does it give you. FastAPI is based on standards, OpenAPI, JSON Schema, OAuth2. These standards and these things allow like a much better integration with many other tools. Because of that, FastAPI can provide you automatic API documentation. Like this thing that you see here on the side, this is generated automatically from your code. You don't have to do anything special to have it just because it's based on standards. So you write very simple code and you get an API based on standards just for free. You don't have to do anything special to get that. FastAPI is based on Python type hints or type annotations. This is part of the Python standard. It's not like a new syntax or anything. We're going to see an example like this a little bit later, but the thing is that these type annotations are what powers autocompletion in your editor and type checks and type errors in your editor. Autocompletion are things like this when you get autocompletion for attributes or of objects, and type checks what tells you that some data that you are using in your code is incorrect and won't work. So the types are the thing that provides autocompletion. And FastAPI is based on these types and is based on the ideas of having autocompletion for everything. So we get autocompletion everywhere in our code when we write code with FastAPI. So FastAPI is easy and short. It's very simple. This code here, this is a completely valid FastAPI application. So we just have to, from FastAPI, import the FastAPI class. Then we create an application object of type FastAPI. And then we use this @ symbol here. This is a decorator in case you're not familiar with this. This thing is just modifying the function that is below. In FastAPI, it actually doesn't modify it. It just like registers it. And what this is doing is it's saying whenever someone goes to the URL / or like the root URL of this application and sends an HTTP GET request, we want this function to handle that request. And what this function is doing is just returning a dictionary with some message. We don't have to return some special type of or class or something. We just can just return a dictionary directly, and FastAPI will take care of converting that to JSON, so we can read JSON on the other side. And by writing this simple code, okay, well, we are writing very little code because it's like quite short. So the more FastAPI code you write, the less API code you end up writing. Like most of the code that you write ends up being the business logic of your application and the code that you need to do to process your data, to run your model, to all the logic that you need to add for your specific application. Because FastAPI tries to get out of the way and let you just like write your code that like the main part of your application. Now, let's say that you have a machine learning model. In this case, this will be a spacey model. So we are doing natural language processing here. We are going to do entity extraction. So we create an object, which is this spacey model, and then we pass some text to this spacey model, and we are going to extract the entities for each one of the entities recognized in this document. So for each one of these entities, we're going just to print what is the text and what is the label. So this model recognized that we have Apple, which is an organization, UK, which is a geopolitical entity or like a location, 1 billion, that is money. So this is just a simple model. This could also be like a TensorFlow model, a PyTorch model, any type of machine learning model that you need to use. This is just like a very simple machine learning processing pipeline to generate some type of value on the other side. So you have a machine learning, an ML model, you have a machine learning model. Now what? What are we going to do with that? So let's make it a web API. Why would you make it a web API? Maybe to show it to your colleagues, to integrate it with other internal apps, or maybe even to deploy it to production or to like build the product right away. So a web API in many cases is like the way that you can communicate from the external world or from other systems or services or even users directly with your model and with your own code. But first, let's take a look at what a basic FastAPI app would look like and what are like the main parts. So we are doing here, this is the same that we had before from FastAPI, import FastAPI, we create the object, we add the same thing that we had before. Notice that this time we are not using an async function. This is a normal function. FastAPI underneath is an asynchronous framework. But if you use a normal definition, a normal function definition, it will do the right thing to make it run in a thread pool or, yeah, well, like the technical details, the thing is that it will work. It will work and it will do what it has to do so that you can just like use normal functions and it will just work correctly. If you know about async and await and these things, then you can like use them and like get all the benefits from them. But if you don't, you can just simply use normal functions and it will just work. Now let's create another endpoint. So we are saying that this is the path that we are going to take. It's going to be /items, and then in curly braces we pass a variable here. These curly braces are the same that we use in F strings, so like the formatted strings in Python. We are just not putting the F here because we don't have a variable item ID, but the syntax is the same, so it's easy to remember. And then this item ID is going to be a variable that goes in the path, and then we are receiving that same variable here in the function. And we are declaring this is a type annotation or a type hint. This is standard Python. We're just saying that this item ID, this is an integer. And then we can like treat this integer inside of the function. So we're saying that this item ID will be of type integer, and we are also adding this extra parameter q, which is of type string, which is by default none. Because it is by default none, then it won't be required. And because it's not of this path here, FastAPI will automatically know that it will take it from the query parameters. So this is how the application would look like. Let's say that we have the application deployed to somedomain.com. We have the /items is this same /items here. And the item ID here is this same item ID here. This is the variable that we are passing, which is an integer. And then this Q will be a query parameter. So the value of this Q will be this some query that we are sending here. Then we are just like returning it just like for the demo. But this is the URL. This is how this will look like and how we will interact with it. But then with this code, when you check the documentation, when you check this URL /docs, FastAPI will automatically generate this documentation user interface based on your code. You don't have to do anything for it to work. We get the /main endpoint that we declared before, and we get the other one that we just declared. Then we have items. We have the item ID, which is a path parameter. We also see it here is this item ID, which is required, and it's an integer. It must be an integer. It goes in the path, and we get the query that goes here, which is the same. If we go back, is this same query that goes here. So just by declaring very simple for you. So you just declared a standard function, and FastAPI does this documentation for you. So you write basic code, and FastAPI makes a docs UI for you. Now, let's say that we want to create a basic FastAPI application that receives a body, because we'll probably receive some data for our machine learning model. So now we're going to say that we want to receive some data that contains an article, and this article is going to be a JSON object, and JSON object is the term for, like, let's say in Python, a dictionary, and it will contain a key content and a key comments. This is like a normal class definition. This is this way of declaring these variables is the same that you will use with data classes, which is a part of the latest versions of Python. And this base model comes from Pydantic. FastAPI is tightly integrated with Pydantic and uses it underneath to generate like all the data validation and the data documentation and all these things. So we are creating this class that is going to have a content, which is a string, and we have a comments, which is a list of strings, and by default is an empty list. Then we can declare a variable here. This is now the same thing that we have been doing. We use the decorator with app, and then we do .post. This means that the HTTP request is going to be a post method, post request. And this goes to /article/, and we are receiving this article variable, which is of type article. And this article here is the same class that we created here above. So we are taking this article, which is this JSON shape, and we are going to receive it as JSON. And then, because the thing that we receive inside is actually an instance, so we are saying that article is of type the class article. This means in normal Python, we are saying this is an instance of this class. And because we are actually receiving an instance of that class, we can use this article dot content. We can use dot notation to extract the values. We don't have to use keys in a dictionary and have to remember what were the names of the keys that we declared before. We can just like use dot notation here. This is just an F string, a formatted string. So we are integrating this content inside of the string. Now we just return this message. And when we check the documentation user interface, we can see that the example value contains the same shape that we declared. So this is the JSON shape or the JSON schema that we will send to the API. It has a content, which is a string, and then it has a comments, which is a list of strings. If we come back, we have the content, which is a string, and the comments, which is a list of strings. So the documentation is also updated automatically with the data that we declared. Now, if we hit, let's go back. If we hit this try it out button in the documentation interface in the browser, we get the chance to interact with our API live directly. And we can just send some data. Like this, here we send this content, and it has some string, and we send the comments. It has some strings inside of this list. We send that to our API that is like running there with our code, and we get the results that we are just sending back. This is the message, and we are sending just the content back, which is the thing that we are returning in our code. If we go back to the code, we are returning message, and this is the article content that we are returning. So we can interact with our data live with this interactive user interface for the documentation of our API. So with just that code, we already made an API with a request body that is automatically documented and like just works and is ready to be used. Now, let's say that we want to build a FastAPI application that takes a body and a query parameter. We can just do the same that we were doing before. We declare one parameter of type article, and now we're going to declare this other parameter big model of type Boolean that by default is false. Because this is a simple data shape. This is not like a complex data shape like this one. This doesn't like contain sub values. It's just a Boolean. The FastAPI will know that it has to take it from the query parameter. And by default is false. So this one is not required. Then we are just returning for the sake of the example. But this is how we can extract something from the query parameter. And if we go to the documentation, this is how we will use it. We go to the URL/article. We will send a post request to this URL with the contents that we are sending. We will pass the query parameter here after the question mark. And this will be big model equals true to make it true, because by default it's false. And the documentation user interface shows us this query parameter that we declare. And because we declared that it was a Boolean value, then it automatically shows the possible options that we have for this query parameter. Also, if we use this in the code, this big model, even though we are sending it in a query parameter, so let's go back again to the URL, we are sending this big model equals true, but this URL is all just like a big string, and like the server is receiving a string. Like there's no like standard for other values in queries or in URLs in general, apart from just like a long string with several parts. But because we declared that this should be a Boolean, FastAPI will take care of converting this big model to a Boolean. So we won't receive like a string containing the string false or something. We will receive a Boolean, right, like we declared here. Okay. We don't have to put everything in the body. We can put parameters like in the query whenever it's like something that makes sense. So we have like those options. We actually have like a lot more options, but let's keep it like that for now. Now let's say that we want a FastAPI application with the machine learning model that we were using before. So this is just the same code. We are just mixing it all together. We are creating a machine learning model. This is a spacey model in this case. We are creating the FastAPI application. We are creating the body that we want to receive with this class that we take from, we create inheriting from the base model from Pydantic. Then we create this decorator app.post. So this is a post request, go to /article/, and this is the function that is going to handle this. It's going to receive an article, which is of an instance of this class article. So this is going to be taken from the JSON body. And we have this big model, which is a Boolean that by default is false. This big model, we're just not going to use it now because it doesn't fit on the screen, but we get the idea of how to get data from the query parameter. Now here we are using the model that we loaded before. This model is from here, and we are using it here to read the content of the article. So we declare that this article has a text content. This is string content from here. We are just passing it through the machine learning model. We get in the document object, and we are iterating for each one of the entities in the entities detected in this document object. What we are doing here is not that magical. We are just like adding the entities to a big list. So for each one of the entities, we are adding the text of the entity and the label of the entity, and we are just returning it. The message contains what is the content of the article, and the entities contain the entities that we detected. Big model just is sending like the same big model parameter that we received. So this is quite simple and quite straightforward. And if we interact with that and we send the data with our documentation user interface, we will receive the data that we are declaring. We can interact with it live and check it like in the browser directly if everything is working correctly. Now, let's say that we have a very complex shape in the data that we want to receive. Now, we don't want to receive a single article. We want to receive a JSON array that contains objects in the JSON body. So we want to receive several of these articles. And each one of these articles inside of it has a comments, which is a list of strings, or like a JSON array of strings. Like the term in JSON is array, but in Python is list, and in JSON is objects, but in Python is dictionaries. But it refers to, let's say, kind of the same thing. Now, we are declaring just the same data, and now we are importing from typing, we import list. This typing is part of standard Python, and this list is part of standard Python. This list is the way that we use to declare that something is of type of list, and inside of it we pass what is the internal type. So this is the same thing that we were doing here before. This is just a standard Python. We are not doing anything strange. We don't have to learn like a new syntax or a new set of classes or anything. This is standard Python type annotations. Now we are declaring that articles should be a list that contains in each one of the items should be one of these article an instance of this class article that we declare. So it will be something with this shape. Now we are doing more or less the same. We are doing an empty entities and a response body. For each one of the articles in articles, for article in articles, we are reading for each one of the comments inside of the comments for this article, and we are processing the comment. And then we are extracting the entities for each one of those comments, and then we are just adding that to the final response, and then we just return that response. So if you check at that, like just saying it in plain English is kind of complex, and still we can fit all that code in a single slide. So this is a fully functional machine learning API. Because like we can just use this very simple standard Python features. And if we check it in the documentation, we can see that the example value is updated. We now have a list. We can see the square brackets here. It's a list that should contain this shape. So the documentation is automatically updated, and the data will be automatically serialized or converted. Like FastAPI will take care of converting all the data that you send to this type of data that we are receiving. So if you declare something is a Boolean or an integer, it will read it and convert it to an integer to read it like in the shape that you declare. Now, what happens if we send invalid data? Up to now, we have seen that FastAPI uses these standard type annotations. So like by default, because you are using standard Python type annotations, independent of FastAPI or anything, by default, you will get autocompletion in your editor, and you will get type checks. We're going to see a little bit more about that in a second. And FastAPI is using those standard type annotations to generate documentation for you. And this documentation is actually provided by Swagger UI, which is a third-party user interface library, which uses OpenAPI, which is the standard that we talk about. So this is just like all based on standards. And FastAPI is also providing you serialization of the data that comes in. But not only that, let's see what happens if we send invalid data. So in this case, we are sending a list. So this is correct. This list contains objects. So yeah, this is fine. This is a JSON object. This is also a JSON object. All these are JSON objects. So that's fine. We send one that has a content. It has some string, Apple buys UK startup for 1 billion, blah, blah, blah. And it has some comments. Nice, it was expected. These are strings, so this is all valid data. Now we have another object which has a content, which is Microsoft creates new project template with FastAPI and space. This one has a content, which is a string. This is all valid, but this one doesn't have comments. But if we check back at the code that we declared, The comments is a list of strings that by default is an empty list. So this is not required. We are accepting data that doesn't have this because we say that by default it's an empty list. If we remove this part, it will be required. But we are not requiring it because it doesn't have to have comments all the time. So this is also valid. But then we send another one that says text, invalid data won't be accepted. And if you check closely, this one is sending a text. This is not a content. And we declared that we were going to receive a content, not a text. So this one is not valid. And this one, it has a content that says this content is fine, but comments. And then if we check the comments, the first one is a string. So up to here, everything is valid. But then this one is a strange JSON object, which has this strange message key, which has a value of, oh no, a JSON object. So this thing here, which is deeply buried inside of the data that we are sending, is actually not valid with the shape that we declared. And if you see, this is inside of a list, inside of a JSON object, inside of another list, and checked as a string. If we try to send that, we will receive an invalid data error that is sent automatically by FastAPI. We don't have to do anything to get this automatically. And we are not just getting an error, we are getting an error that tells us exactly where the problem is. So we can see that the error is in the body and it's in the index 2. So here we have a list of errors. This is the first one. And this is in the index 2. If we go back, this is index 0, index 1, index 2. So in index 2, we have an error. Now, what is the error? The error is in content. And if we see here, we have text instead of content. And what is the error? That the field was required. The content field is required. We didn't send the content field. Now we can see the other error, which is in index 3. Whoop. So this is index 0, index 1, index 2, index 3. And in index 3, inside of the comments, index 3 inside of the comments in index 1. So this is index 0 and this is index 1. What is the error? The error is that the string type expected. So this was expecting a string type. So we can get data that tells us that the error in all these things was exactly here and here. And we don't have to do anything for FastAPI to do it for us because we are declaring the data with, let's go back, here, where this is standard, like PyData is like a very nice library that uses these standard type annotations. But we are using PyData internally, so we can just use standard Python annotations, and FastAPI can do all the data validation for us. So for this code that you write, for this code to execute, you just have to declare, for this code to execute, the data has to be valid. So this code won't be executed if the data is not already valid. FastAPI will take care of giving you only valid data. This is saving us, I don't know, 10, 50 lines of code or something, because we can just take care of the business logic of our application instead of having to do all the manual handling of validating all this data. So if we send this invalid data, we get an error. So with invalid data, FastAPI won't receive it, and the code inside of our application won't even be run if we send invalid data. So we don't have to take care of that after declaring the data shapes. Now we have been talking about autocompletion. How is this autocompletion thing? What is the idea with that? Here we are declaring a parameter articles, which is a list of this thing article. And we are getting autocompletion inside of our code, even for deeply nested data structures. So we are iterating for each one of the articles. We're iterating for this article in all the articles. And then we're iterating for each one of the comments inside of that article, which is coming from the list. So this comment, if you see, is inside of a nested for loop. And we are getting autocompletion in this nested data structure. This is very difficult to achieve with other ways to declare these data shapes if they are not using standard Python type annotations. But because FastAPI uses these standard Python type annotations, we can just like get autocompletion for free in the code everywhere. Also, notice that this comment was not something declared by FastAPI. This is your own data. So you declared your own data here, and you are getting autocompletion for your own data in your code. And type checks. If we go back, this comment comes from here. This comment we declared that is part of this article.comments, and this is all strings. So this comment should be a string. If we try to perform an operation like this string plus some integer, we will get an automatic error in the editor telling us that, hey, you cannot sum a string with an integer. So we can see like a lot of the errors that we could be writing in our code even before running the application. And this is all based on standard Python type annotations. Okay, now let's talk about the metadata. Let's say that we have our application, everything is fine, it's cool, but we want to add more documentation. So we had this big model thing, which is a Boolean. Now we want to add this description here. So we can, from FastAPI, import this extra thing, this query. And now instead of having the false that we had here with the default value, we are using this query here. And we are adding the description inside of this query for this big model, which just says, use the big model. And if we go to documentation, we can see that the documentation now has this description that we added, use the big model. But now the place that we use for the default value, we are using it to add this extra metadata. So this query thing receives as the first parameter what will be that default value. So we can still keep the default value that we were using, that we had before, this false. We just pass it as the first parameter to query. And now query is not a required value because it has a default, which is by default false, and we have the additional metadata. We can also like add a doc string for just like the string that is like the first part inside of the function, and it will be used as the documentation for this API endpoint. And there's like several places that you can just add documentation for your data inside of your code, so that the documentation is tightly like close to the thing that it is describing. So you don't have to write documentation outside of the code that is actually running the thing. You don't have to keep updating a wiki somewhere else so that the front-end team doesn't come complaining that it's not working again because you're just updating something. Because everything will be kept in sync because you just write the documentation right in your code. Now, let's say that we want to add a required query parameter. So this is going to be, let's say that we want to add a language, and this is going to be a string. And because this is a simple value, this will also be taken from the query parameter. The same way that we do in Python functions, because we didn't declare any default value here, we are just declaring the type as a string, then FastAPI will interpret this as a required parameter. If we check the documentation, we can see that lang is now a required parameter. If we try to execute it, to execute this request as it is, like even the user interface won't let us before adding the required query parameter. And if you use like curl or some or code to call this directly, you will get a validation error if you send something without the required query parameter. So when you send data without the required parameters, your API won't let it just pass through. Now, let's say that we send some valid data. So this is actually valid. This is how we will send it in the URL. After the question mark, we pass lang, and this is going to be equals to n. Sorry. If we send that, then we will get the result as we expect. This is something to have in mind. One does not simply make all query parameters required. Have in mind that it's not common for APIs to have required query parameters. So if you need to have a required query parameter, document it well, and well, it will be documented automatically. But just have in mind to not add a lot of them because it's probably not going to be expected by the clients of your API. But still, you can do it if you need it. Now, let's add some extra validation. Up to now, FastAPI is taking care of making sure that if it's required, we provide it and that it has the shape and the value that we declare. But we can have additional validation. Now, we are going to say that this lang parameter should have a minimum length of 2 and a maximum length of 2. So we are going to use a code for the language. For English, it will be EN. And we add this validation here, and then FastAPI will take care of performing that validation. It's actually all done through PyData. But because we no longer have, we are now using this default value that we didn't have anything here. So this could mean that this will be, in a Python function, this could mean that this will be a not required parameter. So to fix that, we can pass these 3 dots here. This means that this parameter is required. And these 3 dots is called ellipsis. This is a Python symbol. This is valid Python syntax. And this is the way we also use in PyData to declare that something is required when we need to add extra validation or extra metadata or anything like that. And we're also using the same query thing that we were using here before, just that for the big model, the default value is false, and for lang, the default value is these 3 dots, which is the symbol called ellipsis, which means that this lang is required. And we check in the documentation and we try to send something that is not valid, so this has 3 letters instead of 2, then we get an error as we would expect. But if we send valid data, then again, it works as we expected. So without valid data, the application or API, FastAPI, will complain. With valid data, it will just go happily and run your code. So now, about performance. FastAPI is actually built on top of Starlet, and Starlet is a framework which is like what gives all the performance for FastAPI. FastAPI is in the top rank the performance available for Python frameworks. This is an independent benchmark. The blue things are Python. The green things are Golang, which is a compiled language. So this is not a fair comparison, but you can see that FastAPI, at least for some situations, can be even faster than some Golang frameworks. Which one of these is the fastest is not that necessarily that relevant. They all get kind of the same ballpark. Like even more, here's Unicorn, which is apparently under FastAPI, and Unicorn is the server itself. So this is not even a framework. This is the thing that runs Starlet, that runs FastAPI. FastAPI runs on top of Starlet. So this one should be on top of everyone else. But the thing is that you get like on the ballpark of the best performance available that you can get, and you get like data validation, data serialization, documentation, and everything for free. And if you check here, we are having more than 15,000 requests per second. So this is actually over 9,000 requests. So this is quite good. Cool. There are some other features. There's a dependency injection system that you can use to do authentication or to do like extra data that you need to reuse in several places. For example, to extract what is the current user, or to do some authorization systems. You can also integrate security tools for OAuth 2 authentication, which is also integrated with the user interface for the documentation. You can have WebSockets. These WebSockets is possible because FastAPI is an asynchronous framework, which is based on Starlet, which is based on the new standard ASCII. Well, those are technical details. The thing is that you can do WebSockets that you wouldn't be able to do with most of the other like established frameworks. You can use files, send files, and it has integrated background tasks. These tasks will be for things like sending an email notification or something short and small that can run on the same process. These wouldn't be to train models. If you need to train models, you will use Celery or RQ or ARQ or some like background task distributed system. But for simple things, you can have background tasks that run after sending the request. There's easy GraphQL integration if you need that, and there's a bunch of other things that you can do. There are other tools. Typer is kind of the FastAPI of CLIs. This is to build command line interfaces. It's also based on type annotations. It's like it should feel more or less the same as using FastAPI. And then you get, autocompletion inside of your core and data validation, all that stuff. But the CLI applications that you build are going to have shell completion for your users. So whenever they use your command line application and hit tab, they will have autocompletion for subcommands, parameters, for everything. And this will work for Bash, C Shell, Fish, even PowerShell in Windows, which is something that no one else provides as far as I know. Like for modern PowerShell and for recent versions, like for Windows 10 and so. Think is the functional deep learning framework based on Python type annotations, which is also compatible with your favorite libraries, so you can integrate it with PyTorch, TensorFlow, whatever you need. And it even has a plugin for doing like analysis of the types and the type shapes of your NumPy arrays. So it can check that you have like at least arrays of the same rank. If you have like a 3-dimensional array and you can perform an operation with it, you need to if you need to perform an operation that only works on the same shapes, it's going to detect them and things like that. When you do like deep learning models. That's what I have for you. Thank you very much. If you want to check the documentation, it's in fastapi.yango.com. If you have questions, I think we can answer them now.
Thank you so much. That was a very interesting talk. Rapid overview of basically everything there is, right?
Yeah, more or less, yeah.
Yeah. So we have been running a bit over time. So I think what we'll do is we'll answer one question live. I think there's a really good one, and then we'll take the rest of them to Discord so we can answer them offline and people can also.
Perfect. Sorry for the delay.
No worries at all. If people need to leave, they can always leave quite easily nowadays. Okay. So I think the biggest question, it's sort of two questions that were asked. What if you have like a big API with several routes in different files, but they need to use the same model? Like, how would that work? How would you structure it? How would you pass the model to the routes?
Yeah, so there's a whole section in the FastAPI documentation about integrating bigger applications with a way that you can separate your all your code and the sections of your API and different API endpoints into sub routers, into API routers. And you can integrate all that in the same application. So you could load your machine learning model in, let's say, one Python file, and then import that Python file from all your other Python files that handle each of the specific sections of your API.
Okay, that makes sense. Would you use the dependency injection functionality for something like this as well, or
you will probably be able to use it. The dependency injection system is very useful when you need to have something that, for example, needs to be independent for each request, like a database session, or when you need to extract data from the request. For example, when you need to get the current user, and to get the current user, you need to check it on the database, and to check it on the database, you extract the ID from a token that comes in a header, something like that. Yeah. Then you can use the dependency injection to get that and reuse that everywhere, because that's data that will depend on each specific request. And the dependency injection system will get integrated into all the OpenAPI documentation and everything. So you get documentation for the things that require all the data to get a user or things like that.
Okay, that makes a lot of sense. So maybe a bit overkill for loading a model.
Yeah, maybe it might make sense in some case. If you, for example, need to load a specific model for a specific language, or if you, something like that. But in other cases, it might make more sense to just load it directly. But certainly you can use it in the scenarios that will work best in that way.
Okay, thank you so much. So we'll take the rest of the questions because there's some good ones. let's take him to the Discord. Talking about the Discord, we have, for each talk that we had tonight, we have a separate channel in which you can ask questions or communicate with the speakers. But also we have a channel called Discussion and Q&A, which is a voice channel, which might also be fun to hang around with and ask these kinds of questions.